Hello everyone, welcome back to my channel. Today let's go over a medium premium question that I just solved on my own. After trying for quite a while, I kept hitting time limit exceeded many times, but today I was finally able to break through, so I'm really happy that I solved this without any assistance. So let me show you what I did. Cool, so basically this is almost like a binary search kind of segment tree question, but you don't have to use a segment tree. You just kind of have to do some workarounds, but basically you're given this array an integer k, you want to return an integer, and you just want to find a particular number where there's at least k inversion pairs. So what that means is, let's say for I in range 1 up to, or let's say up to, I don't know, 10 to the power of 9, because right now you have this constraint. And then what you want to do is basically say, okay, we want to see if there are at least k inversion pairs, which means that for each index there's at least one element that satisfies these conditions where this is greater than, or this is greater than some element on the right, and then the difference, this minus this, is less than or equal to I, which we've chosen. So it gets a little confusing, but basically if you play around with it a little bit, you'll find that we can use binary search. So you want to find this midpoint, which is going to be between 0 and the top constraint. So cool. So now we want to count if there's at least k. So basically for I in range, length of nums. For j in range, I plus 1 length of nums, because we have to satisfy this constraint. And then we have to say if nums of I is bigger than nums of j, and nums of I minus nums of j is less than or equal to this threshold that we're looking for, then that's another one. And then we have to see if this condition is true at least k times. So if answer is bigger than or equal to k, then obviously we want to minimize the result. So let's declare that. So right equals mid minus 1, otherwise left equals mid plus 1, because we're still trying to find this threshold. So in that case, minimum of result and mid. So this is really what we're looking for. And then at the end, we can just return result. If result didn't change from the beginning, then there's no answer, as it says right here. So let's run this. So this technically works, but I was like stuck here for the longest time, and we have to basically find this without n squared. So basically this is the challenging part, but you'll get up to 824. But now what we want to do is say, okay, so we want to find all the elements to the right that are less than the current element. So we can use a sorted list. And let's say now is sl.copy. And then now we just say now.discard nums of I, and that just gives us everything to the right of it. But then again, we want to make sure that it has to be bigger. So let's see here. So 1. Okay, so this is sorted and it's everything to the right to the current element. But we also have to see, is this bigger than anything to the right? So that's kind of the challenging part, but we're going to do a bisect left. So finding anything that's bigger than it means anything to the left of it, because that's already in sorted order inside of now nums of I. And so this helps a little bit, but basically now let's print nums of I, and then now up to be left. So you can see that means that everything in the right hand is smaller than the current value. And then we can just say for A in now up to be L, if nums of I minus A is less than or equal to mid that we've chosen, which is possibly an answer, then we do this. So again, that technically works, but it's going to be too slow. So how do we find this A where the current minus this X number is less than or equal to mid? So if you make some observations here, we'll let this time out again. We'll try to say bisect left inside of now up to be left nums of I minus mid, and then so let's actually print nums of I minus mid, nums of I plus mid, and then let's print now up to be left. So that should give you a clearer picture of what I mean. So here, for example, where is it? So, okay. So for example, if we want to print nums of I, now, excuse me, now up to be left and then mid. So basically here, it's getting messy, but we want to find a number. Okay, this minus whatever is less than or equal to 6. So show you here what that means is, okay, why it's a better example. So this minus equal to this is less than or equal to this. So the number in here has to be between 1 and 17. So this minus whatever less than or equal to 8. 10 minus 2 is less than or equal to 8. 10 minus 18 is less than or equal to 8. So numbers have to be in this range. So let's call this a low. And that's going to be the minimum of nums of I minus mid and nums of I plus mid, because they could be flipped around. High is minimum max. Nums of I minus mid, nums of I plus mid. And then now we just say left is low, right is bisect left. So all the numbers between this range, instead of now be left high, and then instead of this we can just say answer plus equals to right minus left, which gives you how many numbers you have between this. So let's submit this. And you're almost there, but this is still a little too slow because you're recreating the list every single time. So you'll get like almost there, 828, 827. But now what you want to do is, instead of recreating the list, let's just go and do this manually. And let's say, okay, at each index, how many elements to the right are smaller? So let's call this n equals sorted list nums. Okay, so let's print, say nn.discard nums of I to get rid of the current one, and let's print nums of I and nn. So let's get rid of this. Okay, cool. So now these are numbers to the right that are smaller. And now you can do the same thing. BLL is bisect left inside of NN, nums of I. And then what we're going to do is use a dictionary. So to the right side, smaller than at this current index location. BLL, NN, BLL. Okay, so cool. So now that's the only number to the right that's smaller than it. Same here. Only number to the right that's small of it. Only number to the right that's smaller than it. And instead of recreating this list, since we're already looking for I, we can just say up to D of I. D of I. So you pre-compute it just once. Let's run this and submit it. Okay. Oh, time limit exceeded on the very last one. Okay. I'm really not trying to make this easy. So maybe if mid is less than or equal to result, then result equals mid. And then min and max might be a little slow. Okay, maybe we can just say if nums of I minus mid is less than or equal to nums of I plus mid, then low is this one, nums of I minus mid. I thought the min and max function was of one time, but apparently not. Else low equals nums of I plus mid. high equals nums of I minus mid. Let's try this. Because now if this is less than or equal to, then we know the low has to be that one. Otherwise, if this is bigger than this, then this has to be the high. So let's submit it. Oh, wow. Okay. So I'm really not playing around this time, huh? Okay. Lord have mercy. Okay, so sol.copy. Okay, and maybe instead of 10 to the 9, we can just do max of nums, because I think that makes it a little better, because we know that the maximum threshold can't be bigger than or equal to the maximum of whatever we have, the maximum value, because there has to be at least k thresholds. And there you go, passes all test cases. So again, this was really hard for me, but again, I'm pretty glad that I solved it on my own without any assistance at the end there. So pretty bad runtime in memory, but this is a pretty tough question, I think. So again, just happy I solved it on my own. So that's it for this video. Thank you for watching and stay tuned for more.